Hey everyone, this is me Rachit and welcome to yet another video. During this coronavirus spread period, I think a lot of us are working from home and I was kind of working on a project and I thought that it would be fun to share with you. So this image that you can see, this beautiful image on the left, this is something which is generated by just this JavaScript code that we have. Only this one function is doing all of this, and I was super excited and I think it's super awesome like how this is working, and I wanted to share this with you. So this is hosted on GitHub. You can check the source code over here, and what essentially is happening is it's a very simple game that we are playing, and how this works is nothing but we start with a random point. In each step we choose randomly one of the bigger vertex and move 50% towards it from our current position, and we keep repeating that. So in case if I want you to show this for 3, and since we move 50%, I'm writing 50 over here and let it run for few seconds, and as you can see what is happening is you are seeing that we are following a random pattern, but it's essentially turning out into a very beautiful triangle which is having some pattern. What I am doing in each move is that from my current position I choose randomly one of the vertices that we are seeing over here, the bigger blue dots. So I'm choosing one of them randomly, and from my current position I am moving 50% towards it. So this is what 3 represents, and since from my current position I move 50% towards the randomly chosen vertex, this is 50. And as you can see, this is a beautiful pattern that came out of nowhere, and this is why I call this chaos in JavaScript. A lot of research has been done into this, and I came to know about this when I was in my university at IIT Roorkee, and I was studying about fractals. So this is a Sierpinski triangle, and I think this is so damn good, but essentially what I tried to do was like, let's say if you increase the number of vertices to 5, maybe then again you will see some pattern. So if I try to run this for 5, actually I didn't see a very good pattern, and that's when I started reading about this on Wikipedia. Let me just decrease this over here. So yeah, if you let it run, if you let this simulation run for a while, you might see some pattern, but it's not very good pattern. And essentially what I thought was that why only for 3 vertices we are getting this pattern. So then I read about it and I came to realize that if you tweak this number, if you do not move 50%, but if you move some other percentage, you actually can get a pattern. So if you try to run 1 upon golden ratio, which is phi, but if I try with inverse of golden ratio, it actually turns out into a beautiful snowflake kind of structure that you initially saw in this video. What I will go what I will do next is basically dive into the code and try to explain you more how this is functioning, but this is totally random, guys. I'm just telling the number of vertices and the percentage distance to travel from my current position to the randomly chosen bigger vertex. That's all I'm doing, and this is happening on its own. Now if you let it run for a few minutes or few seconds, you can actually see that pattern. But I mean, this is totally like confusing, surprising, and exciting for me at the same time. And I actually wish I knew this much of JavaScript, and it's quite easy. As you can see, only this much of code, and we will come to that in a minute. But it's so damn good, and again, you can play this Stranger Things music over here, just because a blank screen is not that fun. It's still fun, but I just added a background music over here, so yeah, you can click and enjoy this. So what I will do now is basically go and make this 5, and in the source code I will make few changes. So let me make that a bit bigger. So over here what I'm going to do now is basically reduce the animation by 1000. So basically you will only actually it should be 1. So I'm basically slowing down this animation for you so that you can understand what is happening. So what I'm doing is nothing but I have these bigger vertices and I am coloring them as in blue color or cyan if you want to call it. And then what I'm doing is center x and center y are the coordinates of the blue dot which will represent my current location. And in every move, what I am doing is I am basically moving 50% or whatever ratio that you have specified over here. I'm moving that much distance towards the randomly chosen vertex. So this is where the target or the randomly chosen vertex is being chosen. And then I am drawing the whole vertices, and my current present position is again drawn again. And then I update my current position based on the new target that we have chosen, which is the random vertex out of the bigger nodes, and I move 50% or 60%, whatever you have mentioned over here, towards it. So this is how it's functioning. And what I would like to do is, since I have slowed this down, I will try to again run this and let you see how this is actually working. So I am going to make this 5, and I am going to make this again, let's say 61.8. Oops, I think I made some mistake. Let's see quickly. 1000 by 1, which means I want to run it every second. Yeah, so this should work actually. Let's click on Amazing. Yeah. All right. So, oops, I think it did not refresh correctly. Or did it? No. 61.8. Okay, so it has not slowed down. I'm actually calling it every second. Oh, okay, I will make it more slow. No, but I'm actually calling it every second. Why is it drawing so fast? I don't understand. I have saved this file, I guess. I haven't. Yeah, actually I hadn't saved the file. Sorry about that. So as you can see, now I have slowed this down, and what you can see is my current position. As you can see, I'm always moving 50% towards the randomly chosen vertex. So in this case, as you can see, if the let's also do one thing. Let's also color the randomly chosen vertex. So if this is my target, let's color, if the current node is target, let's color it with red. Otherwise, let's color it with cyan or cyan, whatever you call it. So now if I refresh it, so this is my, so now you can see in every second what is the randomly chosen vertex, and I am moving 50% towards it. So as you can see, I'm choosing a randomly chosen vertex and moving 50% towards it. Alright, so this is how it's functioning. And basically, if like I have slowed this down, if you basically increase the speed, you can actually see that pattern. So let's do that as well. Let's make it run really fast, probably, or let's make it 10x faster first. So now I think you can see a bit faster and clearly also at the same time. So we are really choosing random vertices. The red node is fluttering here and there, but it's so beautiful. Like you can see that this bigger triangle, which is always empty, you can see that it is forming, and similarly the smaller ones are forming again. So this is a Sierpinski triangle, which is a fractal, but it's so damn cool that we are just doing random stuff. We are choosing randomly and moving 50% towards it, and we are getting this. I mean, this is awesome. And the good thing is, I mean, the bad thing is this 50% pattern only works for this triangle. If you try to move 50% for a square, or let's say for a pentagon, you won't get any good pattern. For that, I have seen that 1 upon 5 is the golden ratio, first of all. If you move in this proportion, so let's convert this to percentage. If you try to move in this this proportion, instead of 50%, you move this percent. It makes things so damn beautiful, and that's what I have also shown you previously. So now what I'm going to do is again make this super fast. Let's say 300. So I have made it 30x more faster, and now I will show you beautiful patterns. Like for example, if you try a square and you try the golden ratio, just see what happens now. Okay, I have to start saving the file, otherwise this is not going to work. So this is 61.8. Yeah. So guys, this is damn cool. I mean, I really like, for golden ratio inverse, no matter what you enter as the number of bigger vertices, whether it's a square, triangle, or pentagon, it's always making some really great pattern. As you can see, it's a great pattern again over here that we are seeing. and let's increase size to 5, and you get the snowflake kind of structure. I think I will also put this red coloring of the randomly chosen vertex also in the production code, because then you can also try this out. Guys, this is beautiful, I think. Again, you can check out the website. It's hosted on GitHub. You can also subscribe to the channel if you like such videos, and make sure to also play this button and show this to your friends. I think this is super cool, and we have a beautiful snowflake just by this much code. Um, you can check out how this works, why I made it, and if you want to check other of such my work that I am doing, I'm also building a game library in JavaScript actually.